Assalamu alaikum wa rahmatullahi wa barakatuh. I am Itsham Ali from University Malaysia Pahang Al Sultan Abdullah. Today my topic is comparison of sensor-based and spectroscopy-based smart water quality monitoring systems for freshwater aquaculture. Basically, this is a review. Um in this paper, my outline is introduction, importance of water quality monitoring parameters, water quality monitoring systems for aquaculture, near infrared spectroscopy and machine learning for water quality monitoring system and uses of machine learning for water quality monitoring system. And at the end, comparison of machine learning based spectroscopy methods and sensor based water quality monitoring systems and challenges and issues. And first of all, in this paper, our contribution is first of all, we comparison between both both systems, sensors based and spectroscopy based. And second thing, we comparison on the base of different type of algorithms. And third is spectroscopy, NIR spectroscopy based water quality monitoring systems. And third one is challenges and issues in this paper we discuss. And first of all, introduction. Seafood is all around the world is very popular. There are different type of species, for example, fish, lobsters, and there are many other species there. And when we're talking about what farming, so it's a it has very big advantages. For example, high sales and supplies, a profitable business, and rich in proteins, and it's a user friendly business. And overall, what is the importance of water quality monitoring system? And importance of water quality importance of water quality. So there are basically five things we consider. For example, optimize growth and survival, stress prevention, disease prevention, economically. For example, when water quality is good, for example, in term of water parameters, for example, pH, dissolved oxygen. So our seafood, our fish are so healthy. And stress prevention is water quality is a key factor when it's reduce the stress of species. And disease prevention is a water quality is good, so less bacteria, so good water quality in term of disease prevention. And economically, for example, is a water quality is good, so our fish or lobster are growth very easily, and we save money in economically. And other next slides is water quality monitoring parameters. So there are a lot of parameters we consider. First of all, for example, pH, dissolved oxygen, electrical conductivity, temperature, total dissolved solutes, ammonia, and we consider, and it has own ranges. For example, pH 7.2 to 8.2, dissolved oxygen 6 to 10 ppm, and these are different ranges of parameters. And what is water quality monitoring system? Basically, water quality monitoring system monitor the basics parameters. For example, temperature, pH, oxygen. They are monitored, and they prevent stress and diseases. And it's a basically it's a good theme. It's a very good theme when you have a fish farming. So when you implement the water quality monitoring system, so your fish farming growth is very good. And water quality monitoring system for aquaculture. So basically, in this paper, we summarize that there are two basic types of water quality monitoring system. First is sensor based, and second one is spectroscopy based. And in spectroscopy based, we have simply highlighted in this paper near infrared spectroscopy based. So what is near infrared spectroscopy? Basically, spectroscopy based is a when light attraction with metals. For example, its mean light absorbance or reflectance to determine the chemical species. For example, in this NIR spectroscopy, the NIR range is 700 to 25 nanometer. So this is a basically near infrared spectroscopy. So machine learning for water quality monitoring system. So machine learning is a branch of artificial intelligence and computer science, and which which focus on use of data and algorithm to eliminate the way of human learning and water quality and gradually improve the accuracy. Basically, machine learning we use the accuracy of data, improve the accuracy of data. So there are a lot of algorithms. So think about various learning algorithms for water quality monitoring system, for example, linear regression, random forest, SVM, KNN, and especially ANN. So there are a lot variety of algorithms people are using for water quality monitoring systems. And basically use why we are using machine learning algorithms for water quality monitoring system. For example, there are five basic concepts. For example, automatic real-time analysis. In this, for example, real-time water quality analysis, reduce the manual testings, and the second one is efficient data processing. For example, when we using machine learning, then you machine learning effectively handle large water quality data. For example, previously, if you're using manually, it's very difficult to handle the large amount of data. So machine learning help the large quantity of data and improve prediction accuracy. So machine learning model provide a high accuracy predictions and reverse model selection. So various machine learning models like decision trees, neural network are chosen based on the water quality and data characteristics. Enhance efficiency. For example, we are nowadays every system want to increase efficiency. So machine learning algorithm we are using for enhance the efficiency and accuracy. And there are two types of basically machine learning based water quality monitoring system, and what there are basically two types of water quality monitoring system, and we connected with machine learning. For example, spectroscopy based and sensor based. In machine learning, spectroscopy is technique used to study interactions between matter and electromagnetic radiations, matters and electromagnetic radiation. And second one is we are using different type of sensors, for example, pH, temperature, and there are a variety of sensor we are using for water quality monitoring system. In spectroscopy we use light, but in sensor base we are using different type of sensor to detect the water quality monitoring system. So basically, this is a comparison between methods. It's become efficient for the result literature based on availability that machine learning based spectroscopy method outcome more comparable and serious sensor. For example, our literature tell us so spectroscopy based water quality monitoring system is a more accurate, more efficiency, quick result, and real time as compared to sensor based spectroscopy. Further accuracy and performance based, especially when we are talking about NIR spectroscopy with connecting with machine learning. So this is a very best combination about machine learning connect with NIR spectroscopy. And the key point in our literature review. So when we connecting machine learning in a special algorithm ANN with NIR spectroscopy, so we get the best result according to the requirement. Next, challenges and issues. So there are a lot of challenges and issues, but in this paper we just summarize the three in terms of 3 points. Data related challenges, for example, in machine learning for aquaculture, so include obtaining lot of data. So it's a many challenges, for example, in terms of accurate, sufficient, and dealing with environmental friendly and maintaining a data labeling accuracy. So another challenge is, for example, algorithm based challenges. For example, when we implement water quality monitoring system, and is the main consider is which type of algorithm you are selecting, and is depend upon the uses, depend upon the parameters. So basically, these are two main parts. And other challenges, for example, in a real time, and is depend upon water quality system. For example, different field have a different type of water quality monitoring system. So there are a lot of challenges we are facing in these terms. And last, future direction. For example, we have some recommendations about we can future direction. For example, enhance machine learning. For example, expand machine learning integration for better prediction and classification. For example, investigate combine with NIR with other sensors and automatic and alerts. For example, embrace automatic and real time response. And it's also IoT integration align more than with IoT trends, and it is environmental friendly. So this is a basically overview of this paper references. Thank you so much. Thank you so much.